Hello, everybody. Today we are going to look at how you find the point of intersection between medians and perpendicular bisectors in a triangle and what significance they have to get us ready for some problem solving with that. So to start, I'm going to show you how to actually do this on GeoGebra, and then we'll get to the note. Okay, so we're going to start by plotting the 3 points of a triangle. So the test in this unit is open book, so you will be able to use graphing technology to verify your work, not to do the work, but you will be able to use it to verify if you have time. And in your conversation or any achievement checks, assignments, I highly recommend that you use technology to verify for that level 4 with critical thinking. So to create a point on GeoGebra, you simply just go to the graphing calculator and you can just start a bracket. And so my first point is 2, 4. You press enter and it automatically calls it A. Okay, so then you can do -2, 2. So again, you always just start with opening a parentheses and that opens up the set for you. So there you go, A, B, C, those are my coordinates. Now, if it's important to you that they're actually labeled, you can right click and go to settings. And then here you can just press name and value for the label. And then press the X to X out of that. Okay, and then it has it there. And you could continue that for all 3 coordinates. So then you're going to press the circle and triangle to get to your geometry tools. And I want to connect the 3 points. So I want to choose lines. I want to choose segment so that it doesn't actually go through the 2 points, but just connects them. So A to B, and then I click B again to C, and then C to A. All right, now I am going to find the perpendicular bisector. And notice that under construct, there is an option just for perpendicular bisector. How easy is that? So then we just click on this line segment to draw its perpendicular bisector. Same thing on this segment to draw its perpendicular bisector, and on this segment to find its perpendicular bisector. So you should notice that all 3 perpendicular bisectors intersect at a common point. And this will always be the case. So for you to actually find out what that point is, you can go up to, where am I going here? Basic tools and pick point and drop a point right on top of that point of intersection. Okay, then you need to change your tool to move so that you just have a cursor. And if you right click, again, you can go to settings and show name and value so you can actually see its coordinates. So 1.33, which is 4/3, and 0.33, which is 1/3. So we will actually be finding this coordinate using algebra in a moment. So I just want to show you that if I move this triangle around, sometimes this point, which is called the circumcenter. So the point of intersection of the perpendicular bisectors is called the circumcenter. Sometimes it's inside the triangle, but sometimes it's outside the triangle. Okay, it can actually be quite far outside the triangle if it's an odd-shaped triangle. So that is not to be concerning to you if you find a circumcenter that is outside the triangle, even on one of the line segments or inside the triangle. All of those are possible. Okay, now what is special about this point is that it is equidistant from all 3 coordinates. So the distance from this point D to A is the same as D to C, which is the same as D to B. So if you want to locate something an equal distance from 3 different locations, you would find the circumcenter and plot it there. Okay. Also, you can create something called a circumcircle. So a circumcircle would be a circle that goes through the 3 points given by the triangle. And then that would mean the circumcenter is the center of the circumcircle. Okay. Because again, the radius would just be the distance between the 3 points, which are all equal. Okay, so let's actually go to the note and start filling this in. So the point of intersection of the right bisectors is called the circumcenter. It can be found by finding the point of intersection of any two right bisectors. Okay, because all three intersect at the same place, you only need to find the intersection of two in order to actually find it. The circumcenter is equidistant from all three vertices, and it is the center of the circumcircle. The circumcenter can be outside the triangle. It isn't always. Okay, so let's actually do the algebra then to find this circumcenter. So first, let's start by graphing the triangle. So 2, 4, okay, which is A. Okay, and then B is -2, 2. And C is 3, -3. Okay, and then use a ruler, please, to actually draw these lines, because you're going to get much more accurate estimations when you so you can check your work when you're finding stuff than my kind of bad drawing there. Okay, so now we basically need to find the point of intersection between two perpendicular bisectors. So therefore we need the equations of two perpendicular bisectors. Oh, don't you wish that was peanut butter? You should eat some peanut butter while you're watching this video. So we need equations of two perpendicular bisectors, so then we can set them equal to each other and find where they intersect. So you can choose any two of the three options. I'm choosing the perpendicular bisector of AB, and then I'm choosing the perpendicular bisector of BC, and then we will again find their POI. Okay, so step 1, AB. So to find the perpendicular bisector, we first need the midpoint because it goes through the midpoint. So the midpoint of AB, okay, so halfway between 2 and -2 is 0, and halfway between 2 and 4 is 3. So 0, 3, that looks right. That's the midpoint of AB. Okay, so now I need to find the slope of something that's perpendicular to AB. So first I find the slope of AB. So 4 minus 2 divided by 2 plus 2 equals 2 over 4, which is a half. Okay, so therefore the slope of my perpendicular is -2. So down 2 over 1, down 2 over 1, down 2 over 1. Okay, it happens to also go through C, which means this must be an isosceles triangle. That's just a coincidence that it goes through C. That is a really terrible line. But hopefully you get the idea. Okay, all right, so now we need its y-intercept. So you can see that its y-intercept is 3. So you don't actually need to go to the work to find the y-intercept, but if you wanted to, you could, put 0, 3 through the equation. 3 equals -2, that's the slope of it, times 0 plus b, and then you get b equals 3. So the equation of AB is y equals -2x plus 3. Boop-a-doop-a-doop. And you can go further down on your page. I'm just trying to do it so you can see everything at once. All right, so now let's change this to green. Let's do the perpendicular bisector of BC. So we need the midpoint of BC. So halfway between -2 and 3 is +1/2. And halfway between 2 and -3 is -1/2. So if you need to do the work to actually get that, that's fine. I'm just saving a bit of time. So 1/2, -1/2, that looks right. That's the midpoint of BC. And it is 1/2. -1/2. You should probably label this pink one as well. I forgot to do that. Okay, so now we need to find the slope of BC, so we know the slope of its perpendicular. So the slope of BC is equal to -3 minus 2 over 3 plus 2. So that is equal to -1. So therefore, the slope of the perpendicular is +1. So that's pretty easy. You just go up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, okay, to create this line. So again, if you're using a ruler, hopefully this looks a lot better. It's supposed to be 4/3, 1/3 is the answer, as we already know. So hopefully your ruler looks way better than my awful drawing. Okay. So now the point of the y-intercept, okay, so we put in -1/2, so y equals m, which is 1, x, which is 1/2, plus b. And when you solve this, 1 times 1/2 is 1/2, and you add it to the other side, b, you subtract it, you get b equals -1, because -1/2 minus 1/2 is -1. So the equation is y equals positive x. So wait, let me just do that. Just x minus 1. That is the equation of the green line. Okay, so it would have gone through that perfectly. All right, so now we find the point of intersection by setting these two equations equal to each other. So -2x plus 3 equals x minus 1. Okay, you move this x to the other side. So you get -2x minus x, and move this 3 to this side. So -1 minus 3. So you get -3x equals -4. Divide both sides by -3, and you get x is equal to 4/3. Okay, which is, as we found before, the x value of the circumcenter. Now to find the y value, you simply put 4/3 back into either equation. I'll put it back into x minus 1, which is 1/3. Okay, so the circumcenter is 4/3, 1/3. So 4/3, 1/3. So it should be about here if I had drawn this green line properly. Okay, again, I apologize. Hopefully you drew with a ruler and it's perfectly beautiful. I promise that on my actual one, see if you can see that? I don't know if you can. There you go. See, it's perfect. It's beautiful. That's what yours should look like. Okay. Okay. So that is how you find a circumcenter. And again, it is equidistant from all 3 coordinates. Now we're going to talk about the centroid. So let's start a new graph here. The centroid is the center of mass. So it's going to be the point where if you put your finger on it, the circle or the triangle will actually balance. So it's what balances the mass of your triangle. So this concept is, obviously we're just learning about triangles, which is pretty basic, but this concept can be expanded upon into much larger objects like airplanes. They use this same similar type of concept to figure out how to balance an airplane and keep it from crashing. So this is actually very useful. And I mean, obviously it doesn't seem super important because we're just dealing with triangles, but it's setting a foundation. So if you're interested in going into, engineering, mechanical, civil engineering, those types of things, this is a useful concept to understand. So to actually create, so the centroid is the point of intersection of the medians. So to create a median, we first need to plot the midpoint on each side. So you just say construct midpoint on GeoGebra, plop them down. And now we need to create that line segment that goes from a midpoint to the opposite vertex. So these are medians from a midpoint to a vertex. And you will notice that they all intersect at the common point, which we call the centroid. Okay, so again, if you had this triangle and you put your finger on that exact dot, it would balance perfectly, assuming that there are no other variables at play. So you can see, no matter how big or small I make my triangle, my centroid will always be contained within my triangle. It's never on one of the line segments. It's never outside of the triangle. It is always contained within the triangle. So if you want to find it again on GeoGebra, you can just click on this, go to these dots, and you can turn on the value. Okay, now what's really exciting about a centroid is there is a much faster way of finding this coordinate than perpendicular bisectors, so you will be relieved. So yes, you can find the point of intersection of any two medians. You can always do that method. Find the equations of the medians and find where they intersect. So similar to our previous example, but now finding median equations. But there is a cheater way of doing it. The centroid is actually just the average of all three coordinates in the triangle. So we can just add them up and divide by 3, and we're done. So instead of wasting our time doing all that, well, I mean, math is never a waste, let's be honest. It's always good to expand our brain capacity, but I guess to divert our time to other ventures that we have in our lives, we will just do the kind of cheater, easier way of doing it. And that's all I'm expecting of you guys. Okay, so you should, though, draw your triangle at all times, and you should draw the medians so that you can visually verify your centroid. Okay, I am going to require that. So to draw our medians, we'll find the midpoints, which we already did before. We already found this midpoint was here. So you can connect that to this vertex with a straight line. Ooh. And we found this median was here, or midpoint. So you can connect this with a straight-ish line. Hopefully you're using a ruler. And that's enough. I mean, you could also find the midpoint here. It would be 2.5, 1/2. Okay, and you should see the centroid is right there at 1, 1. Okay, this is the midpoint of AB. This is the midpoint of BC. And this is the midpoint of AC. Okay, so the centroid, there's no fancy way of doing it. We just write centroid equals. Okay, you just take the 3x values and add them together. So 2 minus 2 plus 3. And you're averaging them, so you divide by 3 because there's 3 of them. That's how you do averages. And then the y value is you just take the y values, 4 plus 2 minus 3, and again, divide that by 3. That's it. So this is just 3 over 3, and then 3 over 3, which simplifies to the coordinate 1, 1, which in fact we can verify visually, and that's the center of mass of that triangle. That is the centroid. All right, so I have a challenge for you guys to do this practice, and I really do hope that you do it, to try to find the centroid and the circumcenter of this triangle. So first graph the triangle, and I actually, graphing the circumcenter and the centroid on the same triangle is a little bit challenging. So you actually, probably after this video, I'll go to your note and give you a second graph so you can graph it again. Because I do want you to verify both the centroid and the circumcenter visually. And that also ingrains the concept of what those points actually are because you're actually drawing them. Okay, so I will give you the answer. The centroid, which is the easier one to find, you should get that it is 4, 0. And the circumcenter, after some work, it takes some work, you should find that that is 14/3, -2/3. So not pretty. It's kind of a gross fraction, but I have full faith that you can get there. So try that. At a minimum, draw it out. And if you didn't get it, we will take it up in class. So thanks for watching, guys. I hope you learned lots.